Moving on to lesson 9.4, rare events, the sample, decision, and the conclusion. Get to know the new terminology for this lesson. Click on each of the words, learn its definition and meaning. When you are ready, click Continue. Let's talk about rare events. Suppose you make an assumption about the property of your population. Now, this is your null hypothesis. Then you gather some sample data randomly, and then it turns out that your sample has the property that would be very unlikely to occur if the assumption is true. Then you might conclude that your assumption about the population was incorrect. Now, remember, your assumption in the beginning was just an assumption. It's not a fact. It may or may not be true. It's just an assumption. But because your sample data are real and the data is showing you a fact that seems to contradict your assumption, you might make the wrong decision about your original assumption because of that rare event happening. So let me throw out a really silly idea. You and a friend go to a birthday party and there's a basket full of those little plastic eggs, and each one of the little plastic eggs has a prize. One of them out of these 200 little plastic eggs has a $100 bill in it. You allow your friend to go first, reaching their hand into the basket, and they pull out an egg and open the egg, and lo and behold, it's the $100 bill. Now, the chances of that happening, the probability of that happening is 1 out of 200. It's very unlikely that they would get it on the first shot. It's not impossible, though. But because it's such a rare event, that might change your thinking to think, well, maybe there's more than just $100. Maybe the assumption of the only one $100 bill in the basket was wrong. So you've got to be careful about rare events and making some conclusion about the original assumption due to the rare event happening. This level of significance is very important. So the level of significance is your maximum allowable probability of making a type 1 error. It's your alpha. A small level of significance would mean the probability of rejecting something that it's true, the null hypothesis, which is true, is highly unlikely. We want to eliminate this error as much as possible. So having a small level of significance would mean that the probability of rejecting the true null hypothesis to be highly unlikely. There are some common levels of significance that are used. Alpha equal 0.1, 0.05, and 0.01. These correlate with a confidence level of 90, 95, and 99. So 90% confidence would go along with the alpha of 0.1, 95% confidence would go with a 0.5, 0.05, and 99% confidence would be an alpha of 0.01. So these are the commonly used levels of significance. Doesn't mean we can't use something else, just means these are common. It all depends on your HA statement. Doesn't matter what your H0 statement is in this case. It's easier to figure out if you're a one or two-tailed test if you're looking at HA. So we know we have pairs of H0 and HA. So let's take the first pairing. H0 is your mu is greater than or equal to some value k. And therefore your HA means that your mu is less than k. Now take a look at your HA. Which direction is that symbol, your less than symbol, pointing? Is it pointing towards the left or towards the right, or not pointing in any direction? Well, the less than points to the left. So this is a one-tailed test. Not only is it a one-tailed test, it's a one-tailed left-tailed test. Okay, so it's a left-tailed test, which is one tail. Now let's look at the next scenario. Our H0 is mu is less than or equal to K, and therefore our H alternative, our HA, is mu is greater than some value K. Now again, look at the symbol that's connected to the HA. Which way is that pointing? Is it pointing to the left, pointing to the right, or not pointing in any direction? Well, a greater than, it points to the right, and therefore this is a right-tailed test, meaning a one-tailed test. A right-tailed test. Now we have one more option. H0 mu equals K, and HA mu does not equal K. Again, look at the symbol along with the HA, and is it pointing in any direction? Does it have an arrow pointing in any direction? No, it doesn't. And therefore that means that it's a two-tailed test. This is not only a left-tailed test, it is also a right-tailed test. It is a two-tailed test. So we need a systematic way to make a decision to whether to reject or not reject the null hypothesis. And so what we're going to do is compare our p-value, which is a calculation we do based on our data, and a preset or preconceived value, which is our significance value. That's alpha. So alpha sets the standard for how extreme our data must be before we can reject the null hypothesis. Remember, our p-value indicates how extreme the data are. That's our actual calculation. Once we do that, we're going to compare the two values and decide, is our data statistically significantly different from the null? So if our p-value is less than our alpha, we're going to reject the null hypothesis. The results of the sample data are significant, and there is significant evidence to conclude that H0 is incorrect belief. And that means that if H0 is the incorrect belief, the alternative hypothesis might be the correct thing to believe. Now, if your p-value is greater than or equal to your alpha, then we are not going to reject H0. That means that the sample data are not significant. And if it's not sufficient evidence to conclude the alternative hypothesis might be correct. So when we do not reject H0, it doesn't mean that H0 is true. It just means that we have failed to provide sufficient evidence to cast serious doubt about the truthfulness of H0. Now, I know I worded that a little weird, but here's the story. We have H0, we have HA. We always test H0, and we're either going to reject it, throw it out the window, or we're not going to reject it. You can think of this as, if we reject the null hypothesis, it's bad, it's no good. And that means HA is the good thing. We're gonna go with HA because we can only have one or the other. If we test H0 and we fail to reject H0, then it's not true, it's just good. It met our standard, it's good, and that means HA is bad. So you can only have one thing being good at any point in time, either in H0 or in HA, but not both at the same time. But since we always test regarding H0, the reject or fail to reject, if we reject, it's bad. If we fail to reject, it's good. The conclusion of the problem is the culminating explanation of what your results were for your test and how it affects the claim. Now, there are 4 possible conclusions in hypothesis testing. For scenario 1, let's say you tested H0 and you failed to reject it. And H0 was your claim. HA is not your claim, but H0 is your claim. Then that means because you failed to reject H0 and H0 was your claim, that's the good thing. So I'll put that in green. And because only one of those can be good, HA is bad, I'll color that red. And our conclusion could be, there is not enough evidence to reject our claim. That's pretty standard language. There's not enough evidence to reject our claim because we failed to reject it. The second scenario is when the test comes back and it wants us to reject H0. And our claim happens to be H0 as well. And our HA is not our claim. Because we rejected our claim is bad. And therefore HA is good. So there is enough evidence to reject our claim. For scenario 3, let's go ahead and fail to reject H0. But in this case, H0 was not our claim. HA is our claim. The problem is, because only one of these things can happen at a time and we're not rejecting H0, that means H0 is good. And that means our claim is bad. There's not enough evidence to support our claim because we didn't rule out H0. For the fourth scenario, let's say our test results came in and we reject H0. But hey, H0 wasn't our claim, and therefore that means our claim is good because we rejected H0. There's enough evidence to support our claim. Now your homework words things slightly different, but I will say it uses not significantly and significantly in terms of the H0 results. If we're failing to reject our results, then they are not significantly different or lower in regard or higher in regards to our H0. If it is significantly different, lower, or higher, then we're going to say we reject H0. The not enough and the not enough evidence is in regards to our claim. So if we say there's not significant difference in H0, then we're going to fail to reject H0. But if our claim is H0, well, then we can say that there's enough evidence to yada, yada, yada regards the claim. So it depends on the wording. Be very careful about not significantly and significantly. That goes along with H0 results. And the not enough and the enough evidence is in regards to the actual claim. And remember, there are 4 possible conclusions for hypothesis testing. Let's run through an example. Let's suppose a baker claims that his bread height is more than 15 centimeters on average. Several of his customers do not believe him. To persuade his customers that he's right, the baker decides to do a hypothesis test. He bakes 10 loaves of bread. The mean height of the sample loaves is 17 centimeters. The baker knows from baking hundreds of loaves of bread that the standard deviation for the height is 0.5 centimeters, and the distribution of the heights is normal. Let's first figure out what are our null and alternative hypotheses, and is the claim in H0 or H1? Now he claims that his bread height is more than 15 centimeters on average. Since we're dealing with average, it's going to be mu. And therefore, if it is more than 15, mu is more than 15, which is an HA. Our claim is an HA, but we can't ignore building an H0. So the very opposite of greater than is less than or equal to. So H0 is mu is less than or equal to 15, HA is mu is greater than 15, and HA is our claim. What other information are we given in the problem description? He bakes 10 loaves of bread. That is our sample size. So n equals 10. The mean heights of the sample loaves is 17 centimeters. Well, the mean is our x bar of our sample, so x bar equals 17. And the standard deviation for the heights is 0.5. Now that's because he's baked hundreds of loaves of bread. That's the population. So it's sigma equals 0.5. Now we want to figure out how unlikely is this if H0 is true. How unlikely is the mean to be 17 for the sample if H0 is true, where the mean is less than or equal to 15? Is this a left, right, or two-tailed test? Remember, look at your HA and see if there's an arrow pointing one direction or the other. Well, mu is greater than 15. That is a little arrow and it's pointing to the right, so this is a right-tailed test that we're going to do. Time to run our test, which means we got to get our p-value. So because we're dealing with mean and we know our standard deviation, we're just going to run a normal z-test. So x bar minus mu all over standard deviation divided by the square root of n. We have all of these values. Our x bar is 17. Our mu is 15. Our standard deviation is 0.5. And our n is 10. So throwing this into the calculation, we get z equals 1.2649. And if we threw this up on the web to find our p-value, or we throw it into the TI-84 in using our normal CDF, we get the p-value of 0.102954. Now we need to compare it with our alpha. If our alpha is not given to us, then we can assume about an alpha of a 0.05. Because our p-value is greater than our alpha, then we will not reject H0. We only ever test H0. We never test HA. It doesn't matter that our claim was an HA. We only ever test the null hypothesis. Because we do not reject H0 and HA was our claim, we will say our claim is, in essence, bad. We don't have enough evidence to support our claim. It doesn't mean that the baker lied. It just means that there's not enough evidence to support the claim that the mean loaves of bread heights are greater than 15. One quick thing more about this example. Our full conclusion has two parts. The first part is in regards to the test, in other words, H0. Since we failed to reject H0, it is not significantly different than what we expected. We always expect the test to come out good. In other words, we always expect the test to not be rejected, meaning it comes out good. That's what we expect. If the test does not come out good, in other words, we reject it, that's when we would say there's significant difference than what we expected. We always expect it to come out good, and therefore this is not significantly different than what we expected. The second part of our conclusion has to do with our claim. Now, our claim in this case was HA. And because H0 was not rejected, meaning H0 is good, that means HA is bad. And therefore, we do not have enough evidence to support our claim. Now, nowhere in there did I say the baker was lying or that he wasn't truthful or that he was wrong. What I said was there was not enough evidence to support his claim. Now, if we run this test on another day, perhaps those results would come out differently. But the sample that we were provided with and that we ran the test on does not have enough evidence to support that his claim of bread heights is greater than 15. And therefore, we say there's not enough evidence to support it. We don't say he lied. We don't say he's wrong. We say there's not enough evidence to support it. In other words, this time around, maybe next time around, there will be loaves of bread that will support his claim. You've reached the end of this lesson.